Oxygen is divalent, whereas sulfur exhibits a valency of 2, 4 or 6. This is due to. Here in case of oxygen, if you see the electronic configuration of oxygen, 1s2, 2s2, 2p4. In the second main energy level, there is no d orbital. So in oxygen, d orbital is absent. But in case of sulfur, electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p4, and third main energy level contains a 3d orbital also, and 3d orbital is completely empty here in case of sulfur. So 3s and 3p is the outermost electronic configuration. 3s contains 2 electrons, 3p contains 4 electrons. It is a ground state electronic configuration. Due to the presence of the vacant d orbital, the electron can be excited from 3p orbital and 3s orbital. In first excited state, the electron present in the 3p orbital can be excited to 3d orbital. Then it will get 1 lone pair and 4 unpaired electrons. Similarly, in the second excited state, the electron present in the 3s orbital can be excited to 3d orbital. Because of that, it will get the 6 unpaired electrons. But this possibility is not there in case of oxygen. Because of this reason, due to the absence of the d orbitals in oxygen, the excitation is not possible. But in case of sulfur, due to the presence of the or availability of the vacant d orbital, it can exhibit the valency 2, 4 or 6. So here for the given question, the answer is availability of vacant d orbitals in the valence shell of the sulfur.